What if data is a really bad idea? Hello, my name is Eric Normand, and this is my podcast. Welcome. Today I'm going to be reading and discussing a Hacker News thread. This one happens to be an AMA, an Ask Me Anything, that Alan Kay did back in 2016. Oh, just about 5 years ago. And it's interesting to me because Alan Kay and Rich Hickey get into a little discussion. And, this is like catnip for me. This is candy. And I ate it up back then, and I've probably read it 10 or so times since then to try to really understand what happened in this discussion. And so this topic was actually suggested to me by my friend Jonathan Sharvit, who's writing a book on data-oriented programming. And I think it would be a great topic. So let's do it. Now, Alan Kay is being asked a lot of questions, and he is also asking questions himself. I think one of the questions he was asked was, like, what are the kinds of things that you're questioning today, and what kinds of questions should we be asking? And one of the things he said was, what if data is a really bad idea? So Rich Hickey responds, and I'll just read excerpts. I'm not going to read the whole thing. You can read the whole thing. I think it's interesting. I just want to highlight a few sentences, pick out things that I think are worth talking about. All right, this is Rich Hickey. So he's trying to get more information from Alan Kay. He says, I find data hard to consider a bad idea in and of itself, i.e., if data equals information, records of things known or uttered at a point in time. Could you talk more about data being a bad idea? So he's just asking for some clarification. What do you mean data is a bad idea? Like, it just means information. Alan Kay says, what is data without an interpreter? And when we send data somewhere, how can we send it so its meaning is preserved? Okay, so this is Alan Kay answering a simple question. Now Rich Hickey says, data without an interpreter is certainly subject to multiple interpretation. For instance, the implications of your sentence weren't clear to me, in spite of it being in English. Some metadata indicated to me that you said it. Should I trust that? And when? But these seem to be questions of quality of representation / conveyance / provenance, which are, he agrees, important, rather than critiques of data as an idea. Data is an old and fundamental idea. Data, something given, seems the raw material of pretty much everything else interesting, and interpreters are secondary and perhaps essentially varied. Okay, so I think, like I said, I've read this like 10 times, so I know more context than what I'm reading because I've read further down and can reinterpret what he means by all this. And of course, I've watched a lot of Rich Hickey talks and read other stuff he's written. Likewise for Alan Kay. So I'm going to try to integrate all of that. Of course, this is up for my interpretation now. But that's why you tune into the podcast. So let's continue. All right, so Rich Hickey is the kind of person who goes to a dictionary when he realizes that he's unsure of what a term means. And so, to me, I think that he perhaps is not he's not being generous with his interpretation of the question with Alan Kay. Okay, so he is saying, well, the fundamental idea of data is that it's information, right? And this is an old idea of like record keeping. It goes down to like at least as far back as the Sumerians, like writing down stuff or keeping stuff, maybe even not in writing, keeping records in like knots and strings and stuff. And this is a really old idea, and I think he's implying also that it's a good idea. And so it's good and it has stood the test of time, right? He's not saying because it's old, it's good. He's saying it is good and it has been refined over the years into an understanding of why it is good and how to work with it. And so he's still asking this same question. Is it like, how can it be a bad idea? Right? All right, so Alan Kay responds. There are lots of old and fundamental ideas that are not good anymore, if they ever were. All right, so I feel like at this point, the conversation is breaking down. Alan Kay is using this rhetorical argument that, oh, here's one little thing that you said, that data is old and fundamental, and I'm going to say, well, that doesn't mean it's good. And I don't think Rich Hickey was implying that. And I think that Alan Kay is also being ungenerous with his interpretation of what Rich Hickey was saying. And just from my experience reading other stuff from Alan Kay, this is actually kind of common that Alan Kay is a very smart person, is very well read, and is used to dealing with people who are less well read and have thought less deeply about stuff than he has. And I think he has a bias to interpret what people say as not having thought as deeply as he has on these issues, which is, the bias probably serves him well most of the time. But with someone like Rich Hickey, who is honestly trying to form an understanding of how could data possibly be a bad idea, I think it's just a mistake to use these kinds of rhetorical arguments about like nitpicking one little point in his 2-paragraph response, thinking, oh, you must think all old ideas are good, right? Which is ridiculous. All right, so Alan Kay continues. The point here is that you are able to find the interpreter of the sentence and ask a question. But the two were still separated. For important negotiations, we don't send telegrams, we send ambassadors. Then he goes on to talk about objects. Of course, Alan Kay invented object-oriented programming. And he says, bundling an interpreter for messages doesn't prevent the message from being submitted for other possible interpretations, but there simply has to be a process that can extract signal from noise. This is particularly germane to your last paragraph. Please think especially hard about what you are taking for granted in your last sentence. Again, the last sentence that Rich Hickey said. Data, something given, seems the raw material of pretty much everything else interesting, and interpreters are secondary and perhaps essentially varied. All right, so I think that Alan Kay in this part, he really is trying to answer honestly. But I'll jump ahead. So I think that they are fundamentally disagreeing about what constitutes data. I think Alan Kay, just from other readings I've done, is using data as a programmer uses data, meaning like bytes in memory, like basically charges of electrons in your RAM chips, that it's all signal. It's some signal that gets interpreted as ones and zeros. It's an analog signal, but it gets interpreted into a digital signal, and then collected together into bytes, and then those bytes have some kind of meaning in your program. They could be numbers. Well, they're all numbers, right? They're binary numbers. But then some of those numbers are representing like integers, some are representing pointers, some are representing floating point numbers, some are representing characters, etc. And he's using data in that kind of like data structure way, in the way we think of it as programmers. And Rich Hickey is talking about data as this fundamental idea that goes back to, like I said, the pre-writing, right? And I think that Alan Kay is not acknowledging that Rich Hickey has said, like, interpretation is necessary, and you can't understand the data without an interpreter. I think that what Rich Hickey is talking about is that the idea of data, of trying to write something in a way that can be understood given certain minimal like levels of common understanding of interpretation, is actually a really good thing. Meaning you're going to write numbers a certain way, right? I'm going to write with these 10 digits, and the most significant digit goes on the left and the least significant goes on the right. Or I'm going to write in English using these letters. I write them in a way so that people can read them. There's a kind of minimum, and this is the idea of data, that we have some agreed upon way of recording facts, and over time we've refined that, and the interpretation is a secondary idea. And he goes on to refine this idea later, so we'll get to that. Okay, but I think that this sentence that Alan Kay says is very important. For important negotiations, we don't send telegrams, we send ambassadors. And this to me shows one of the fundamental disagreements or misunderstandings that they're having. Alan Kay is trying to talk about a way of scaling systems by sending something more intelligent than a piece of JSON, right? Something more intelligent than pure data over the wire, and having higher level communication than you can get from a single message getting sent. Okay, and this is this shows to me that what Alan Kay is doing is trying to get at a fundamental research question. Often when you're doing research, you ask these kind of almost silly questions and try to uproot some fundamental premise that you've made. And if you've made this idea that we can just start with data as a given, and that's what we'll base our whole network on, our whole system of computing. If you start with that, you get a certain system, right? But what if we go back and think, what if we don't pass data between systems? What if it was a bad idea? What else could we do? And he's trying to use this analogy or a metaphor of telegrams versus ambassadors. If it's an important enough negotiation, a king will send an ambassador and not just a message. And so this is, I think that although the discussion is going off the rails, I think that he's asking a really interesting idea. And we shouldn't just say, oh, he doesn't understand like the actual dictionary definition of data. Of course, it's a good idea. I think it's worth asking. Okay. And the discussion is going off the rails. It in fact ends after several long responses. All right. So here Rich Hickey is going to answer. And he's trying to say, without the idea of data, we couldn't even have a conversation about what interpreters interpret. Okay, so again, this is like a rhetorical kind of question. An interpreter can't interpret anything if there's nothing called data for them to interpret. So how could it be a really bad idea? We're talking about interpreters. We're both saying that, yes, interpreters are important. Rich Hickey says maybe they're secondary to data. But Alan Kay is saying, like, but what about the ambassadors? And Rich Hickey is saying, well, the ambassadors are working with data as well. And how can it be a really bad idea? Even if you don't use data, like the idea of data is bad? All right. So now he's trying to, I think Rich Hickey is honestly trying to kind of explain what he means by data. Take a stream of data from a seismometer. The seismometer might just record a stream of numbers. It might put them on a disk. Completely separate from that, some person or process, given the numbers and the provenance alone, might declare there is an earthquake coming. But no object sent an earthquake coming message. The seismometer doesn't know an earthquake is coming. So it can't send a message incorporating that meaning. There is no negotiation or direct connection between the source and the interpretation. Okay? Now this is, I think, a pretty good explanation that there's some signal that is getting recorded, and that record is the data, right? And that record can be interpreted by something, a person or a computer program, that could interpret that as an earthquake is happening or coming or whatever. But there's no direct connection, and another person could interpret them in a different way and declare, no, there's no earthquake. If you meant to convey, so he's saying like that idea of like writing down what the seismometer said, separate from the fact that, you know, a certain person decided it must mean there's an earthquake coming. Separating those out, that is important, and that is the idea of data, and that is good. And how can that be a bad idea? If you meant to convey data alone makes for weak messages / ambassadors, well, okay. But richer messages will just bottom out at more data. Data remains a perfectly useful and more fundamental idea than message. In any case, I thought we were talking about data, not objects. I don't think there is a conflict between these ideas. So, okay, he's saying even the ambassador and the other, person that the ambassador is talking with, they're exchanging messages with data, right? And message is going to be a higher level idea than data. It all is data at the end, right? It's just words that are going back and forth between people. And it's got to be a useful idea. And we're talking about whether data is a good idea or not about whether there might be some other good idea, like objects, that there's no conflict. You can have two good ideas. All right, so Alan Kay responds. Second paragraph. How do they know they are even bits? How do they know the bits are supposed to be numbers? What kind of numbers? Relating to what? So he's commenting on the second paragraph, which is that paragraph about the seismometer. So Alan Kay again is pointing at like this fundamental idea that you might have a signal, but you need an interpreter. All the way down to the very bottom, you need something to interpret. Like I was saying before, you have in your RAM, you have transistors that are carrying a charge, and a positive charge is a 1 and a negative charge is a 0, right? So that's already one level of interpretation, whether it's positive or negative. And then on top of that, you're interpreting this collection of charges as a byte. And then maybe you put 4 bytes together to make a number. And there's interpretation after interpretation after interpretation, all the way down to, you're basically figuring out what charge is happening in a certain piece of material, like a microscopic piece of material. And so you're interpreting it, and then of course your program's interpreting that number in a certain way, and like eventually you're dealing with like some domain terms. And that is cool. That is magic, right? But Hickey is going to respond. He's like, that's not what we mean by data. Okay, that's certainly not what the dictionary means by data. So let's see what he says. Hickey. It contravenes the common and historical use of the word data to imply undifferentiated bits/scribbles. It means facts, observations, measurements, information. These are /facts/observations/measurements/information. And you must at least grant it sufficient formatting and metadata to satisfy that definition. Okay, so it's finally coming out more clearly what Hickey means by data. That he's assuming because of the dictionary definition, that it doesn't just mean like bits in memory. It means an actual fact recorded in such a way that you can read it, right? And that's understood how it should be read. Now, of course, you can interpret it in different ways, right? You can interpret, just as an example, if you write down, let's say your weight every day, right? Which a lot of people do. You just record your weight, and you could interpret, oh, my weight is going up. Oh, I'm losing weight. That's one interpretation. But another interpretation that someone else could draw is this person was concerned about their weight. They took the time every day to write it down, right? So there's always multiple ways to interpret it, but you write it down in such a way that it is clear that it is a weight. If you have, at least something in common with the other person, you can read numbers, you can read the units and stuff like that. All right, but that is what Hickey was saying. And he's saying any other issues, like whether you can read the numbers or whether you understand the units, like let's say in 1,000 years they're not using kilograms anymore, and so like you don't understand what a kilogram is, which happens. You read like an old book and they use some weird measurement system like furlongs, and you're like, how long is that? Right? But you would still say that's data. Like it could be interpreted. Right. So, he's going back to the dictionary and relying on that. Now, again, of course, I think he's correct given the interpretation that he is making of the word data. I think that he's absolutely right. But is he really reading is he digging too much into, like, do we have the same definition? And not really reading into, like, well, what could Alan Kay mean by this? And to be fair, he was trying at the beginning. He was asking a lot more questions, like, what do you mean it's a bad idea? How could that be possible? And then Alan Kay was picking on, like, well, interpretation. It always requires interpretation. And then it finally comes out. He's like, yeah, but that kind of base level interpretation is included in the definition of data. Like, if you can't see that like he gives an example, like, you can't just write the number 42 and call that data. It doesn't contain enough information to interpret what that might mean, right? Okay. So I think that at this point, he's right in a technical sense, but he's wrong conversationally. He should realize that, oh, wait, maybe my definition of data is not the one that Alan Kay is using. And instead of kind of giving up, which I feel like is what he does, he should instead, try to piece together what Alan Kay is trying to say if he wants to continue. So someone else, Alan Kay stops in this thread for a minute, or for the rest of this thread, but someone else jumps in and tries to explain what Alan Kay is thinking. I think what Alan was getting at is that what you see as data is in fact at its basis just signal and only signal. A wave pattern, for example, but even calling it a wave pattern suggests interpretation. What I think he's trying to get across is there a phenomenon being generated by something, but it requires something else, an interpreter, to even consider it data in the first place. All right, so I think Rethinking understands that's what he's saying, but then Rethinking says, if we can't agree on what words mean, we can't communicate. This discussion is undermined by differing meanings for data to no purpose. So I think, like, this clearly states that Rethinking thinks that they're disagreeing about the term. But he never asks, what is your definition of data? Right? He's kind of digging in and is like, I looked it up in the dictionary, like, I can't be wrong. And like I said, technically I think he's right. I think that this is a very good definition of data. It is a very useful idea. And that he shouldn't dig in. He should instead say, okay, we have a different definition of data. What is your definition? Right? So now the Rich Hickey continues, not the way I suggested, but in a different way. The defining aspect of data is that it reflects a recording of some facts/observations of the universe at some point in time. This is what data means and meant long before programmers existed and started applying it to any random updatable bits they put on disk. Okay, interpretation of those observations is completely orthogonal. Data is not merely a signal. What constitutes minimum sufficiency of data is a useful and interesting question. E.g., should data always incorporate time? What are the trade-offs of labeling, being in or out of band, per datum or dataset? How to handle provenance, etc. That has nothing to do with data as an idea, and everything to do with representing data well. Okay, he goes on later and says this. Sometimes we want the facts, and other times we want someone to discuss them with. That's why there is more than one good idea. Data is as bad an idea as numbers, facts, and record keeping. Science couldn't have happened if consuming and reasoning about data had the risk of interacting with an ambassador. The ambassador can lie. They might not have the facts. You have different facts, right? You want to do science by looking at the data. So, I mean, like I said, I agree with Rich Hickey on his technical points. I think data is a good idea, and it's worth answering the other questions that he said were interesting. What are the trade-offs of labeling being in and out of band, right? So in-band labeling means you have a JSON where you've got the keys as strings, so you can interpret them, in band. And then otherwise, something like protocol buffers, where there's a schema that defines what each thing in the structure means, but you have to look at the schema if you're a human to figure out what to do with it. These are important discussions, and they're all about data as an idea. But the fact that there's better and worse implementations of data is separate from the idea of data and whether it's a good idea. Okay, now Rich Hickey got a lot of attention there because he wrote more, and I think it was a good idea and worth digging into. But Alan Kay does answer other people's questions in this same, this as a response to his same initial question. Remember, that initial question is, what if data is a really bad idea? Now, if we look at some of the other stuff that Alan Kay has said, one thing he says in the early history of small talk, which there is a podcast episode on, is he talks about wanting to get rid of the idea of data structures. Now, from my perspective in 2021, it sounds equally silly of an idea to get rid of data structures. Data structures, that's a really important idea. We couldn't have good computer science and good high performance programs without them. But it's useful to look at it. Okay, there's two things that I've learned about this inquiry, this line of inquiry, that I think I should bring up. First, Alan Kay is not as careful with his words as Rich Hickey is. His mind operates really quickly and with a synthesis of ideas from all sorts of places, and also from within the context of his own time of when he wrote these things, right? So him wanting to get rid of data structures, if he wrote that in the early 80s, but referring to a time in the 60s and 70s, maybe that means something different at that time. So data structure to me is something like hash map, a linked list, even something like an array list. These are things that I'm used to having given to me as part of a library, and I just have to kind of know their basic properties, right? Okay, it has linear, sequential access. This one has random access, etc. But if we look at it from his perspective, and from, we have to interpret what he was talking about. Programs at the time that when he was thinking about these ideas, a data structure was a fundamental part of your software. So optimizations, let me put it this way. if you were writing a custom piece of software, you might have to write, let's say, a routine to do spell checking. So this routine would have to quickly find, given a, like, let's say a word or even a misspelled word, quickly find, does this word exist in the dictionary? And then what are the words that are near it in terms of edit distance? All right, so this is a hard problem if you have a slow machine and not a lot of memory. And so you might write a custom data structure, meaning you are writing, basically a tree with pointers and little arrays of memory that are structs that represent different things, and they point to other things. So your code has to know how to walk along these pointers and locate the piece of data that you need that is stored in this structure. And so you're going to have this, like maybe a for loop that walks along the structure. And then one day you say, oh, I know, we can cut out a lot of the search if we do XYZ. And so you go into your for loop and you add a little if statement that says, well, if this is the case, then we can cut out this and we'll skip the left branch. And we'll just go right to the right branch. But otherwise, we have to go to the left branch. So like you are writing very custom logic into the walker, into the for loop that walks along this data structure. That is what he means by get rid of data structures. That's the data structures that he's talking about when he says get rid of them. We don't want our business logic, like the word we use today, to be mixed in with the logic for walking pointers. Everything has to be custom, right? We want some kind of modularity between, okay, you're going to get a linked list, but it's totally generic. You're going to get a B tree, and it's totally generic. And we'll give you an interface for walking it, but you're not going to develop your own custom ones every single time with their own custom algorithms as you keep adding to and finding special cases for and modifying. That's where we go wrong, and that's why nothing scales, because we're always just in our for loops. We need scale, right? And maybe you can find a better data structure than the B tree for your particular problem, but it'll have the same interface and you'll be able to just swap it out, right? That's the magic of the modularity that you get with object-oriented programming. It's not that there aren't data structures. It's just not the thing that you focus on, and it's not where all of your code winds up. You write the B tree once and you reuse it and it's fine. Okay? And this was a hard problem. No one knew how to do that back then. And it took creating this whole system of, classes with constructors so that they knew how to build themselves and initialize themselves. And then message passing so that you could interpret the message. Say the message is basically give me a sequence of all the nodes, like walk the nodes in order, like depth first search, and I'll tell you if when we're done, if we find what we're looking for, right? So this is an interface onto a B tree, but you could imagine that same interface working on other data structures as well. Your code just has to know how to work with that interface and not how to follow pointers. Okay. So someone once said that one of the things object-oriented got rid of was the idea of pointers, because you're not dealing with structs in memory that point to each other anymore. You're dealing with references to discrete objects. It's not like continuous memory that you have to wade through. It is discrete objects with references to discrete objects with discrete APIs, right? So I think that's a good way to think of it. So with this interpretation of what he meant by get rid of data structures, could he possibly mean something similar, like if we were generous with our interpretation of his question, what if data is a really bad idea? And a bad idea for what? There's not a lot of context there. Later on, he does have some context. So here's one of the responses to one of the questions. This is why the objects of the future have to be ambassadors that can negotiate with other objects they've never seen. Think about this as one of the consequences of massive scaling. Okay, so this is more context. Massive scaling of software systems. We want our systems to be able to scale more than linearly. And so far, we this is my interpretation, but we're always working on a super linear curve that has an elbow when we're scaling our system. We're writing systems, and at some point, it just slows down to the point where no new features happen. And all we've been able to do so far is slightly push out the elbow. So we're still kind of in that linear pre-elbow part of the curve, right? And at some point, even all the best practices, all the best languages, at some point still hit an elbow and go super linear. And so we need to find ways of pushing out that elbow, right? And so he's trying to push out the elbow to galactic scales. And what if data is the thing holding us back? Okay, that's more context. Of course, it's not just all in here. I've read a lot of stuff from Alan Kay, a lot of his talks and everything. All right, so let's read another response. Elsewhere in this AMA, I mention an example of this, a resurrected Smalltalk image from 1978 off a disk pack that Xerox had thrown away that was quite easy to bring back to life because it was already virtualized for eternity. This is another example of trying to think about scaling, in this case temporally, when building systems. The idea was that you could make a universal computer and software that would be smaller than almost any media made in it. All right. I think, well, maybe he does go into this in another section. He talks about, I'm not going to read it, I'll just comment on it. He talks about TCP/IP and how that was a great idea because it allows computers of different architectures and different, different machine codes and everything to communicate. And it was and it's a very small spec. And he said one of the secrets was that the message did not have any structure except for the envelope. Right? It just had the packet and it defined how to interpret a packet. And you could put anything in there. And other systems, for efficiency or just general lack of vision, wanted to put stuff in there, it's more structure. But TCP/IP succeeded because they said, no, we don't know what people want to send. We don't know what computers want to send. We can't possibly think 1,000 years into the future what they will want to send. But we can come up with this general envelope and make hardware or software that can open up the envelope and have this packet. And then there's also the slash in TCP/IP. So IP just talks about the packets, and TCP has a very lightweight process for doing a handshake and keeping a socket open and reconstituting packets. Reconstituting a stream of data from individual packets. And it deals with packet loss, and it deals with out of order, and it deals with repeated packets. But it works. To reconstitute, in general, it works to reconstitute this. So what he's getting at is we need another thing on top of that to deal with computation. We've got the, quote, data layer figured out. We know how to get streams of data whizzing around the internet. What we don't know how to do is to have something that is the actual interpreter of that data. Yes, it would be built on data. Okay, fine. But we shouldn't just be building these, bespoke pieces of software that run on, a particular platform and then send data to each other. Because now you're just back down to the data layer. What we want to be able to do in order to scale better is have some other thing, let's say a small virtual machine that could safely run software from somewhere else that would ride on top of the TCP layer and allow for a richer way of communicating, of computing, than simply sending data. That is what I think he means by what if data is a really bad idea. We need a way, we have the way to send data, but what we don't have is a way to send the ambassador. This interpretation. Here's some data, and this is how I think you should interpret it. Right? This is a way to understand this data. And more to the point, I think, so going back to what Hickey was saying, that the idea of data has to assume that it doesn't just bottom out with signal, that there's some basic idea of meaning in it, right? Somehow encoded in it in some way that you expect to be able to read back in, right? That's just assumed in there. Like 42 is not a fact, but 42 pounds is a fact. And better would be Eric weighs, I don't weigh 42 pounds, but at this time, this person weighed this much on this scale, and you can just elaborate what a good record of that would be. What Alan Kay is saying is, yes, in human terms, we've all agreed, we've been to school, we know how to read, we know how to, read numbers and interpret dates and English, and we know the units that we're all using. But what if we didn't have to? What if we could have a system where you could communicate, let's say, with another planet, like people on Mars develop their own network. People go to Mars and then there's some divergence. They have their own computer factories there. We have computer factories here. They have different gravity on Mars. So like maybe weighing using pounds is not an option there. There's all sorts of stuff. And like you're diverging and now you want to communicate again. So he's really thinking galactic scale, right? You don't want to just send a stream of data. You want to send an interpreter. Look, these are just bytes I'm sending. Like TCP understands the idea of bytes. So we've got that covered. But the idea of pounds, the idea of a date, the idea of it, like all of this has to be agreed upon out of band. How can we and computers like can't they're diverging, whereas in some ways human education is kind of converging, right? We all go through the basics at school, and we're all kind of taught to be similar enough to communicate. But like computers are diverging. What is the minimum amount that they need? What is that minimum schooling that a computer needs to be able to communicate just that one level higher than data? So that's my interpretation of this question. And I think he just didn't phrase it that well. What if data is a really bad idea? That invites all sorts of discussion about what data, like the definition of data, and what does it mean to be a bad idea, and can something be a bad idea but still worth questioning? Those are the kinds of things that Rich Hickey was trying to explore and open up. And I have this trouble a lot with Alan Kay talks, where he'll say something like this and he means something really big, but I think the words just don't express how fundamental he's trying to get, right? And I think it's a very good line of inquiry. It's a very good research topic. Like, how could we scale the computation of the internet? Not just the data sending abilities. And that's basically what it has now. In one of the responses, he talks about how, you could think of JavaScript as a kind of bad VM, but at least it's universal. And you could compile down to JavaScript, and you could define your VM on top of that in terms of JavaScript, at least because then it's universally runnable. But all these things are just kind of adding up to this interpretation that I have, that he's really asking something like this unanswered question, the next step in what the people who developed the internet were trying to do, which is build on top of a very small layer, right? It's got to be small, on top of the stack that we have, the network stack, that would allow things to allow programs to move freely. And how can you do that safely? Like, these are all very open questions that we don't know yet, but they're good lines of research. And what would it look like? And how would a program that finds this kind of sent over the wire and reconstituted startups running, how would it communicate with the other things that are running on the same machine? Or how would it find what to communicate with? Because it can't be a complete program. We know that any program has all these dependencies and stuff. You don't want to send everything every time. Maybe you do. Maybe that's an open question as well. But how would, if you're like a genie out of a bottle and now you need to get stuff done, to fulfill your purpose, what do you do? How do you communicate this? And so he talks about stuff like you could start to establish common baseline things and some kind of basic protocol that's defined in that virtual machine. All these things I think are really worthy research topics, and I'm glad someone is kind of banging their shoe on the desk to bring these back up. All right. Thank you so much for being there, for listening, for watching. My name is Eric Normand. This has been another episode of my podcast. You can subscribe. That would be great, because there's other episodes coming soon. And Well, I'll just end it there. Thank you for being there, and as always, rock on.